Hello and welcome to my video for Demo 9, our final microprocessor. This is the last and final rendition of our microprocessor that we saw at the start of the semester. As you can see, we added quite a bit to it. We went over the ALU in the last video. We added that, the four additional select modes. And yeah, we'll just be going over the anatomy of the circuit, logic, and how it acts in sequence, or how it acts in action, I guess. So, yeah, we have here on our left, we have our logic, our next state logic, which determines the behavior of our two flip-flops. Control logic, which determines the sequence in which our read and write and other miscellaneous functions will function in sequence. We have our address generator, which allows us to choose which two ROM units we will be doing our operations through, as well as the random access memory module that will be storing that output in. And we'll go over, we'll see soon just how that's passed through here. Let's start with a very rudimentary example. I guess for address A, we'll choose ROM 0. I did not mean to rename that. Excuse me. 0. For address B, we'll be doing ROM 1. Leave that as is. For RAM, we'll do RAM 6. Why not? And then for values, we will be subtracting 8 by 2. Should get a 6. Let's see what happens. Oh, forgot to start. Okay. Alright, we see our B value come up here, get stored in that, our A value coming up, going to the ALU. Here we see our output, which should be going through the accumulator and then bust through to our RAM. And voila. Here we can see there we go. Here is our output of 6. How about another example? Let's do something that we've added. Let's do division. For this, we'll use RAM 5. And let's keep the values the same. We'll be using the same ROMs this time around. Should get us an answer of 4. Excuse me. And I forgot to set the... It's always important to set the select modes. So let's... 4, that's the leftmost bit. Alright, now let's see what happens. We see our B value go up. Our A value goes to the ALU, through the accumulator, and then out to our RAM unit. And voila, we got our dividend right there. Let's use different ROMs this time. Let's do ROM 3. And then let's do ROM 2. Our RAM unit will be number 7. Let's do bitwise XOR. Our values will be 1, 1, 1, and then let's do 0, 0, 1, 0, which should get us 0, 1, 0, 1, which should translate to 5. Decimal. Let's see that happen. And there we go. There is our XOR output. So yeah, that is how this final microprocessor functions in action. Yeah, that is the circuit in a nutshell. Thanks for watching.